So this talk is highlighting several efforts to support our end users of remote sensing or scientists in the journey to the cloud. So my name is Amy Steiker. I'm part of the NASA National Snow and Ice Data Center Distributed Active Archive Center, or NSIDC DAAC. And the other co-authors listed here are also part of other NASA DAACs and are part of the NASA Openscapes effort. So NASA Openscapes, we are a mentor community. Kind of goal and aim is to, we're co-creating and teaching common tutorials to support our researchers as they migrate their analytical workflows to the cloud. So again, the speakers today are a subset of this larger group, and many of the efforts that we're highlighting are part of this collective effort. So I want to acknowledge everyone in the NASA Openscapes group. Next slide, please. So this agenda, this talk is going to kind of have a series of shorter lightning talks. And we're going to sort of brief you all on some of the ways that our DAACs have started supporting end users in this sort of transition to this cloud paradigm. And the why is, so that we can share and learn from each other, grow and improve our DAAC support of our cloud archive science and application users. And we're also teaching and supporting, open source and open science best practices.
All right, so I'm Alexis Hunzinger. I am with the Goddard Earth Science Data and Information Services Center, and I am one of the NASA Openscapes mentors. So as Amy just described, as a smaller group of representatives, we have learned together, developed tutorials together, and taught together. And so now our responsibility is to go to our own DAACs and share that information. The Goddard DISC, we hosted a workshop for our staff members with the overarching goal of letting them experience working in the cloud just like our users will. So our strategy was kind of a three-phased approach here. So the first phase was to educate our staff ahead of time using the materials that we developed that were geared towards our users that we published on our website. So these include glossary terms, FAQs, informational paragraphs, how-tos and tutorials, and also a table on the status of which data sets are cloud enabled. Then after that, once we solicited interest in our workshop, we surveyed our staff to get an idea of what their Python programming experience was like and also their computing experience. Because we knew we had such a broad range that we wanted to make sure we could teach to where everyone was at. So we broke them down into groups. And then finally, we held 3 different teaching techniques that we learned within NASA Openscapes, which really involves that typing along with the instructor to get people's hands dirty, so to speak, to see if that code would solidify and that they understand what's happening. So how did it go? Overall, we had positive feedback. Most people felt more confident after the workshop, whether that was with Python or with understanding working in the cloud. You can see that in total, we had 33 staff participate and a roughly even breakdown of beginner, intermediate, and advanced levels. And then our feedback was maybe as expected. There was a lot of positive feedback when it came to how we structured the workshop, some surprises about using GitHub, and it was really critical that we were able to use breakout rooms and a virtual setup to help people troubleshoot along the way. Some complaints or things we can improve on. With any workshop, especially if it's virtual, window and tab management was a big issue, which I'm not sure what the solution is on that. But other things that we could fix is limiting the amount of material we teach, slowing down on the typing with the live coding, because it is hard to keep up when you're, again, looking at many different screens, and then doing a better job of getting that jargon and terminology defined and continuing to define it as the workshop goes on. And then finally, we just asked staff what knowledge they wish they would have known beforehand. And many just wish they knew a little more Python, a little more AWS and cloud terminology, and some more familiarity with the tools that Earth Data already provides. So overall, the takeaway from our staff workshop really was to lay that foundation with cloud basics and terminologies before you start teaching, and then just to continue to support staff as they have questions and as they continue to experiment in the cloud, just as we are continuing to experiment in the cloud.
Great, thanks, Alexis. So I'll jump right into going through some of our end user training events and some of those outcomes. So I won't go through this list in a whole lot of detail, but this is just to kind of give an example of all of the cloud training events that we have hosted and supported essentially in this past year. The Cloud Hackathon at the top, this was a really successful cross data center effort that was spanned a week of interactive, Jupyter Notebook-based tutorials, and then also kind of giving the participants a chance to hack and play around with kind of some of their own use cases and needs, and sort of building upon the tutorials that we taught. So we also hosted an AGU workshop, and then a couple of other kind of more NASA mission specific workshops focused on kind of those more individualized user communities. So moving into outcomes, we surveyed the participants of each of these events, and we asked a lot of the same questions, which was really helpful to see kind of what themes emerged across those events. And I think that this plot here really speaks volumes as far as how much sort of the cloud comfort level increased compared to after this event compared to before. So you'll see in this plot, we went from kind of before, as the majority of participants, this is from the Cloud Hackathon event in particular, we had about, I want to say 40 or 50 or so participants here that had little to no cloud experience. And then after the event, this really ramped up kind of 2 notches, and most users most of the participants had an intermediate kind of comfort level. So this really, I think, highlighted how valuable these hands-on events are for teaching some of these cloud kind of, this basic understanding of what it means to work in the cloud. One of the verbatim comments we received was, I think, really highlights this as well. So, we need better documentation on how to access, and that it would have been extremely difficult to do any of this without the help of the hackathon. So again, I think this really speaks to how important it is for us across our data centers and working across the DAAC to be building a lot of these tutorials and teaching in this kind of hands-on environment. Another kind of key outcome was understanding the why. There's a lot of concepts that, and maybe some misunderstandings or unknowns that a lot of participants face kind of going into some of these training events. And we really kind of took home from this that, there was a lot of kind of conceptual improvements in some of these conceptual understandings of why and when to use or not use the cloud. So we also recognize that there is a significant learning curve and time investment required for adoption. So that was another thing that we understand kind of at a fundamental level. So some other quotes here, is really eye-opening to not be constrained by my local computer. This is not, this is a big paradigm shift for, as far as traditional kind of download methods and relying solely on that computer for not only, storage, but also compute. And then more realistically, I'll probably use many of these tools on my local machine unless I'm working with big data sets. So again, also understanding the why and when, I think was really helpful. I think we a lot of our participants gained a lot of understanding there. Moving into pain points. And I think this is where, we focus as far as, what can we do to help improve this? So the big one is we still have, a lot of inconsistencies when it comes to data availability and service offerings. And I think this is really, I think, a core kind of issue that we want to help address, especially when it comes to, reuse and extendability. So when we talk about, open science and that ability to kind of reuse and adopt from an existing workflow, this is something that I think is really important, again, that we address. The next is lack of common and robust learning resources. As we talked about, I think it's really important that we are building these common tutorials for our users. And also this note that, currently the Earth Data Cloud ecosystem is complex and overwhelming. There's a lot of vocabulary that our participants need to learn, and kind of this question of when and why to use a given workflow or tool or service. There's still a lot of options, and understanding, when they'd use something and why was really important. And then, this quote at the bottom, I think, is also pretty powerful, and kind of the sentiment that maybe our cloud-based tools are not mature enough to use in research-focused applications. So, this is another thing that that's important to address, and we'll get to in one of our next talks on Earth Access Python library as one way to kind of solve some of these issues. Okay, slide. So just to wrap up, sort of moving forward where we're at, I'll kind of start at the bottom with these 2 key bullet points that, we really recognize that hosting a common cloud environment. So that's one of the things that is fundamental across all of these training events. We have a Jupyter Hub that is set up with a predefined kind of curated environment that all our participants can use, and that this easy cloud access really should be a fundamental service. It is very difficult to do this without having that infrastructure in place. So that's kind of what you see in the top left as well. And then, continuing to close the loop between the users we work with and our engineers to build solutions together. So this is something we are working on, across NASA, sort of the NASA Earth data, everyone working across NASA Earth data, essentially to kind of pull those pain points and user needs in to make our services better. So you'll see kind of some other items here. As far as spinning up a permanent cloud environment, so kind of going from that stepping stone, how do we teach users how to kind of do this more permanently? We're also working towards other kind of concepts with advanced cloud processing. And then, I think across all of this, as I mentioned earlier, this open science enablement and also teaching these kind of key collaboration tools and methods is sort of part of a theme across all of our events as well. So with that, I will move over to Luis to talk more about Earth Access.
Yeah, so I'm Luis Lopez, and I'm also working at the NSIDC DAAC, the data center. And as a part of this input from the scientists during these different hack weeks and hackathons, we started to develop this library to make things simpler for them. So initially we got some input on like, well, moving to the cloud is a steep learning curve, and you have different data centers. Scientists don't necessarily focus on one. They sometimes use data from different DAACs, and there are some complications with that currently in the cloud. So we took all of this input and started to develop a Python library that will integrate with one of the most used workflows or stacks that Earth scientists use for Earth science data, which is the Pangeo or PyData stack, which is X-Array, NumPy, Task. So that's the ethos of the library, making things simpler for the scientists to access NASA data, regardless of where the data is in the cloud or not. So the next slide, please. This is a little bit of that steep learning curve when you move things to the cloud. Like we are used to, like, you have a URL, you download your file, and then you start doing your computations in your machine. But well, that's not scalable once that you get to certain threshold of big data, and there are other things that why we're using the cloud. So once that you move to the cloud, the scientist or anybody that wants to use it in an effective way have to learn some of the concepts that are like some cloud related specific to Amazon, some other are specific to NASA. So it's a kind of a fragmentation problem. And for a software engineer, well, you learn those things and then you go. But for geoscientists, they're not like cloud engineers or experts in all these APIs. It can get complicated, and we noticed that in the Hack Weeks, and that was a complaint. So once that you get to the notebook terrain, that carries on, and it's the same complication. You get like different libraries, and you have to be aware of certain concepts. So with all of that, we started the library to make things simpler. And the thing is that they know the data, they just don't know the cloud. So one of the things that we did was, okay, so you know the data, you don't know the cloud. We're going to wrap the things that you need to get to the data with this library. And an important consideration for this is that we're working at the granular level. So in NASA, if you're familiar with these granule things, are like the discrete chunks of data, the files that each of the data sets are partitioning to. So if you work at this level and you don't require pre-processing, or you're going to do the pre-processing for your work, then this is perfect because it doesn't do GIS operations yet. Like you cannot yet do the transformation that other services will provide for you. And if you're not a cloud expert, so I don't know, AWS, so you can use early access for things that you normally would do. So the next slide, please. And if you see here, the code is quite simple. It's like 4 lines of Python. You import the library, you get the data, the granules on the spatial temporal parameters, and you stream that to X-ray. And this is for level 3 data or graded data. And there you go. You don't need to learn anything AWS specific. And that's kind of like a very powerful. This is proof of concept. We're still in early development. And there is a notebook there in the slide that if you go there, you'll see the power of this approach. This notebook originally was developed by DAAC, and they are doing very common analysis, the sea level rise analysis with a DAAC data set. And you get to that analysis, which is real science, not a toy example, with very few lines of code, very open and reproducible science, which is, well, that one of the objectives of doing this kind of analysis. And there are some things that we still are working on or would like to work on technically, that overcoming those will make things simpler for the scientists. But the most important, I think, will be even more engagement from the community. So that's the repository in GitHub and NSIDC. Currently, it's called Air Data, but it will change to Earth Access. And finally, this is a community effort, like Amy and Alexis said. And there are more people that are not in this photo that make all of these things possible.
All right, thanks, Luis. So just wanted to quickly close and wrap up here. And as you've seen, I think there's a lot that, again, we are kind of learning together as a kind of mentor community, that we are teaching and learning alongside our end users as well, building a lot of the tools to help support them, as Luis mentioned, as we're supporting our broader community, like Alexis mentioned as well. And I want to really close by emphasizing how much, as I mentioned at the end of my talk, we are incorporating, kind of open science best practices, and both within our own mentor group, but also educating and supporting those workflows alongside, along with the journey to the cloud of our end users. And so I wanted to emphasize the importance of that, and that's been something that's been well received and really valuable component of our educational resources.